All right.
Oh, there he is. So handsome.
Yeah. Working.
Well, thanks everyone for coming. You all good to go?
Good to go.
Appreciate you being here to our second ever Solidity deep dives, led and educated through the great Colin Nielsen. Just before we get going, quick shout out to the sponsors. First is Cryptorado, which I think almost everybody, a couple people don't, but Cryptorado is just basically a local organization that kind of gets people together for stuff like this. So there's an event calendar and a meetup page that are sort of a hub for crypto related stuff going on. There's also a Discord channel that you can jump into and talk to people and find places to meet and things to talk about and that sort of stuff. The other sponsor is Bullet Network, which I will let Colin explain.
Yeah, Bullet Network is the project that I'm working on full time. It's like an on-chain accounting and commerce protocol. We've got a kind of a cool, slick invoicing, payroll, and payments app that works on a couple different chains, and they're sponsoring the pizza and a little bit of the space for us to come in. Massive shout out as well to Thrive. They've been super accommodating around every corner, and they give us this great kind of turnkey space here to come and use.
Yeah. Before we get started, are there any like initial questions about what we're doing, who we are, who the sponsors are? Cool. I think we're gonna turn the lights out. It feels like it helps the vibe and the screen seeing. If anyone gets scared, just scream, and we'll turn them back on. It is spooky season.
There you go. Spooky.
What's
So
the
spooky.
agenda for it?
That's a Colin question for sure.
All right, Colin, what's the agenda?
All right. Yeah. So, few housekeeping things. Overall, yeah, so overall, I guess the purpose of this group is to, if you weren't here for the first one, the purpose of this group is to have like a solid and consistent learning group where people can meet up, ask dumb questions, ask smart questions, stop each other in the middle of sentences and ask like, well, actually, I don't know what that means, right? I feel really convicted about education and especially like learning in the open together. One thing that I felt really shocked about when getting into Solidity was the lack of resources. If we're going to make resilient smart contract DeFi ecosystems that are permissionless, immutable software, we better make sure that we do it right. And it just seemed like there was a huge disconnect there, and the amount that was at stake and the little there was to know or to learn just by reading up online. So kind of the purpose of this meetup, just to like set the tone, set the atmosphere, is like hop into a repo, go through some common patterns that we see that can make us better, at the, I guess like at its very least, just like increase our understanding of the space, and then hopefully make us better Solidity programmers, better contract engineers, share ideas, share learnings. So I am just trying to point us forward in a direction, and then hopefully we can branch off from there. I don't know if some of you either got caught up and saw the first episode or this is your first one, but I think kind of the style here is that we just hop in, we teach each other, we ask good questions, we ask dumb questions, we come from a bunch of different backgrounds, and we hopefully leave this room being able to write better software. So this is like a more technical meetup. We'll go through a certain repo to understand kind of some of the patterns that they use, why they do what they do, and yeah, what makes Solidity and the EVM kind of tick, and then share all the wonderful learnings there is on the way there. So yeah, any questions, any riffs on that? Today we're going over Uniswap V2 repo, Periphery repo. Cool. Yeah, so just a few things. I put the HackMD link in the meetup comments as always. So if you go to our meetup and if you scroll down to, there should be a comment section. Oh, I have to be signed in. I silo apps I don't trust on Google Chrome, which I also don't trust. So there we go. I'm signed in here. Yeah, so here's the stream link. Here's the HackMD link. And so you can hop on there, check those out. What we did last time is we shared a bunch of useful links, things like that, that we kind of used or touched on in the meetup. So this is just kind of a boilerplate to get us started, but anyone with the link has edit access. So throw a bunch of stuff in here that you think is relevant, that you think is cool for us to all kind of go back and look at later once the YouTube video is published from the stream. And then they'll be in here. So just to start, I've got one useful link here, and then the repo we're gonna go over today. Cool. Yes.
It says 4 to 3 forbidden.
For on the HackMD?
Yes. Yeah, you may need to open it.
Oh shoot. Yep.
You need to write down there. Only me.
Yep. Good. Thank you. Publish. Okay. So this should be the link now.
Yep, it's working.
It's working now?
Yeah, I see it.
That's simple. All right, cool. Easy. Sweet. Okay. So what we're going to talk about today is the Uniswap V2 library. You know, like I said, if we're going to go over DeFi standards, this one is pretty quintessential for a standard. There's been, no major exploit. There's been no hack. Uniswap has set the bar in terms of what a repo should look like, what docs should look like, certain smart contract patterns that we take for granted every day, kind of were first seen in this original V2 repo. It's what kicked off DeFi summer. It's pretty legendary across the board. So we're going to talk a little bit, philosophically about the periphery and core model of building smart contracts, why that's important, and then we're going to kind of dive into some of the functions of the Uniswap router, how it handles tokens, and how to kind of set up a mental model for how these things work intra-transaction, which I think is really important. A lot of interesting caveats about the EVM come out to play in the router, and the router is built to protect the user ultimately. So yeah, like I said, I don't know. I'm no expert of the Uniswap V2 library. I know enough to kind of to use it. But if you know, I'm sure there are a few people who know more than me in this crowd. So if you know stuff, hop on in, cut me off, ask dumb questions, and we're gonna kind of go through it. I guess just to start off, show of hands, who's familiar with the Uniswap V2 library at a code level? Cool. 1, 2, 3. Cool. All right. Sweet. Nice. Yeah. So hop on in, share your learnings with me as well. So I think a good place to start here is going to be kind of to talk about how Uniswap has set up their different libraries. So if we go to their GitHub, you'll see a few things here. You'll see the V2 core, and you'll see the V2 Periphery. Just to mention briefly on here, like Uniswap V2 is one of the most forked projects out there. It is a great model for like how you could make a permissionless ecosystem for swapping between tokens and trading tokens, and it's really responsible for like the vibrant DeFi ecosystem that we see here today. So we kind of see like, but anyway, back to their contracts, we see a separation of concerns here. We have a core repo and a periphery repo. And this is something that is also seen in the Aave V3 contracts. So if we look at Aave, we also see the same kind of pattern. We see a core and we see a periphery. And so like this is a pattern that's really kind of starting to emerge in DeFi is, well, I think it's certainly emerged already with Uniswap handling it the same way. They have a V3 core and a V3 periphery as well. And so like I wanted to talk about this like a little bit as well. Also, I've got this whiteboarding kind of app here, so we'll see how this goes. This is my first time using this, but like there's some reasons why you might want to do this, right? So let's say if we have like a core part of our repo, let's say we're building like a DeFi ecosystem, we want to have like a core and a periphery system. Why might that be, right? So first of all, if you imagine your smart contract ecosystem, you imagine like, okay, I have this smart contract that interacts with users and with tokens in a certain way. There's business logic that I believe makes my contract special and will bring users to it, right? So in the case of Uniswap, you say, hey, there is business logic here that allows users to take token A and swap it for token B. I have USDC, I want ETH, I can trade, right? No one has to know my business. I just go to a contract and trade. That's really interesting. Or Aave, right, where there's like a little more, definitely more complex, but it's like at its core, there are, this protocol will allow me to lend, right? Or it'll allow me to swap. So what you might want to do when you're designing like a DeFi ecosystem is you want to have like your core contracts, which do a few different things. You want to make sure that your core contracts maintain invariance. And they perform like business logic, right? This is a more like philosophical, like how do we design our software, right? So at its core, we have types, so like a data model, and then above that we'll have logic, how the user will interact with that data model and what sort of functions are exposed to them, right? Is everyone who here is like not familiar with the term invariant? Because I wasn't like a few months ago. Okay, yeah. So an invariant is something that never changes, right? So for example, in the Uniswap V2 library, the invariant is as such, very famously, is x times y equals k. That is something that never changes, right? So Uniswap said, okay, we want to build a contract ecosystem that allows people to swap. What's the most basic invariant there is like, token A, the amount of token A times token Y, the amount of token A times the amount of token B is gonna always equal a constant, right? So you're going to create a core contract that maintains an invariant around a certain business logic, right? That like allows a market to define a price, but kind of always allows, it maintains kind of this one sort of invariant, which says that which allows these pools to kind of be in balance, right? And so one of the main reasons why you would want to have a core and then a periphery contract is because when you start to think about smart contracts like this, where you have like a core contract that just has like logic that's maintained, is what you start to do is you actually push risk to the edges of the system. to the edge of the system. That's weird. Okay, that's fine. So when when I just have like a core contract, like for example, we'll see very quickly in this Uniswap library that it's actually dangerous to interact with the Uniswap V2 library directly. We always want to use it through the Periphery ecosystem. So when you're designing smart contract ecosystems, think about what's most like essential to your protocol. Create a system of invariants and have the core contracts maintain those invariants. And then everything else that you need to do that's like user focused, that makes the user friendliness, makes it safe for a user to interact with. That's what you're going to put in the Periphery contracts, right? So like in the case of the Periphery contracts in Uniswap V2, these are going to help me. These contracts are going to help like prevent slippage, prevent front/back running to a certain degree. It's also going to help me just like it's a friendly interface for the user to signal when I want my trade to happen, when I want my trade to occur, and then also like certain parameters like minimum, like the min received, like min token output, right? So this is what the Periphery contracts does is like, for example, right? Like if I went to a trader, right, or if I went to a broker, right, or a marketplace, and I said I want to swap 1 ETH, and I see that the price now is $1,200, right? And maybe my broker gets back to me in a week, and they're like, "Hey, we found you a good deal today for ETH. It went down to $900, and so we sold it for you." And you're like, "What the heck? Like, I had 1 ETH, but you traded it a week later, and now I got like $900. You consider that like a bad broker, right? Like they're not handling your user needs correctly, right? So we in the core contracts we sort of create this system of invariance. We push risk to the edges of the system, and then we use the Periphery contracts to sort of safely interact with those contracts so that we're not all trying to handle all this complex business logic at this core contract. Is that kind of tracking? Does that make sense? Another thing that I also want to mention too, like in this separation of concerns here between core and Periphery contracts, we actually have a very important phenomenon, and that is like ERC20 token balances, right? And so, as you all know, only one user can be assigned a certain amount of ERC20 balances, right? So like these core and Periphery contracts, like while this is cool in like to philosophize about, they literally also exist at like a different contract address, right? So the core contract address is these different swapping contracts are going to exist at different at different addresses on the Ethereum network. So you've essentially you've we're really messing it up there. You've essentially siloed your risk, right? Because this Periphery contract will almost act as like a delegate that like points and moves contracts across the blockchain and makes sure that certain things happen, and takes advantage of the atomic nature of transactions. And then you have the core contracts, which are just made to do a certain amount of things, right? And so like in building good software, you really want to, there's a huge emphasis on, especially in functional programming languages, there's a huge emphasis in like pure functions. So like, given a certain input, an output will always be the same. And it's a very safe and easily testable way to program. And so kind of this is a similar flavor, but a different medium of having pure functions exist on chain. You've got these core contracts that hold tokens, and then you've got the periphery contracts, which move tokens to the core contracts. So this is kind of, I guess, the philosophy here, and I think this will make way more sense once we actually hop into the code and start to see this. But this was really helping me think about building like a smart contract ecosystem for, I guess, like V2 of some of the bullet contracts, is to think about this sort of separation between core and periphery. Our stuff isn't super DeFi, so it's not as necessary, but yeah, it's just like really helpful to keep this separation of concerns in your mind. Think about what contracts are doing which logic and which contracts are holding which tokens.
Is this invariance, I'm guessing, is part of why you see V1, V2, V3 type stuff?
Mm-hmm.
Do you know if there's kind of like some level of accepted, if you change this much of those core invariant contracts, then you should probably consider it a new version versus just whatever 0.1 patch type deal?
Right. Yeah. No, that's a good point. So that's a little bit of a finicky question in terms of blockchain anyway, because the contracts are non-upgradable unless you make them upgradable, and then kind of they should be upgradable. I think there's definitely like a breaking point for sure where you've actually I'd say, like, my gut reaction is that, like, when you change the interface enough, so like maybe you do a patch upgrade on a smart contract, and how those subsequent smart contracts are deployed and iterated on, that maybe is just like an underlying logic change. But if you are changing the interface of a smart contract and fundamentally like how data is reasoned about, I think that's yields V2 to V3, V3 to V4 kind of change, because you have to update your front end, you have to update your data model if you're using like the graph or something like that, because you fundamentally change what the data means, not just like how the data is processed, right? Like Uniswap V3 is crazy because it has this whole idea of like liquidity bands, right? So you provide liquidity only within a certain price range, and like, so it's fundamentally changing how the contract is interacted with. V1 to V2 is a little bit more similar, but definitely much more user friendly.
I also have kind of like a oversimplified analogy. So it's kind of like you have a car, and your core would be like an engine. So like V1 or V2 might be like, oh, it's a V8 or something, and then V3 is like, now we're electric. So it's like for the end user, it's still a car, still the same thing, but like the underlying core is now different. Like it's like a completely different thing. So that's kind of how I look at it from a simple high level.
Yeah, I think that's a great way to do it, right? Like I've got a 2003 Land Cruiser V8, right? But it's essentially like the core contract is that 4.7 liter V8 engine, and then the periphery contract is going to be the the Tundra or the Land Cruiser, or right? It's like it appears on different models, but like the core is the same. Cool. Any other thoughts, questions, feelings, desires? Cool. Sweet. Yeah, let's hop into some code. Okay. So here we've got the V2 Periphery repo and the V2 core repo installed, or I guess cloned down. So normally how these repos work, just as like a little interesting tidbit, is you'll have like a contracts folder, and usually at the base here is you'll have kind of the contracts that you need to that are kind of like shipped, right? Like normally this stuff here is boilerplate. So if you ever kind of come into one of these repos and you see like, in contracts there are all these like folders, what's the deal here? What are the things that I usually have to pay attention to? It's gonna be the stuff at the base level, right? So at the root, at the root of the directory, of the contracts directory, we have, the V2 router version 2 and the V2 migrator. We're going to talk specifically about the router today because it's like, I guess just that's what we're going over, and it'll reveal quite a bit about the V2 core contracts as well. Let me just set my compiler version to 0.6.6. Okay, cool. Let me pull up like an outline of the different methods here. So who here has like ever used like Uniswap or SushiSwap or I don't know, any kind of weird derivative like Stella Swap or I don't know, boy swap, girl swap, whatever. Like it's okay, cool. If it swaps, it swaps. That is true. So let's just get like an outline here, right? So we've got quite a few different functions, right? So the V2 contracts are pretty simple. You've got a V2 pool, which has asset A and asset B. And then this router contract is really concerned with like, how do I interact with those pools in a way that is safe for the user? So yeah, just to do like a quick rundown of anything with an exclamation point is a public function. So those would be functions that like I would interact with. So you've got add liquidity ETH, remove liquidity ETH, remove liquidity with permit, remove liquidity ETH with permit, right? So we're starting to see like a lot of duplicates here. Remove liquidity ETH supporting fiat transfer tokens, remove liquidity with permit supporting fiat transfer tokens, swap exact tokens for tokens, and these are going to be the ones that we kind of use when we swap, right? Swap exact tokens, swap tokens for exact tokens, swap ETH for exact tokens, swap tokens for exact ETH. So kind of we're noticing that there's this like, arbitrary tokens in, specific out, specific in, arbitrary tokens out. There are these different sort of wrapper functions that interact with the pool. Swap exact tokens, swap exact ETH for tokens supporting fiat transfer tokens. So there's like, as you can see, there's kind of like, there's a few different wrappers that they use to handle ETH transfers, to handle token transfers, situations where I want, depending if I want a certain amount in or if I just want to get the max amount out, and that's all handled. And normally that's stuff we don't think about when we interact with like the V2 repo is like, I just hit the max button, but I don't think about how that might be a different function on the router call and how I'm protected as a user. So we'll look into that a little bit here. Anything with the tree here and or eyeballs, it's going to be a tree is a pure function, and eyeballs is a view function. So these are like utility stuff. So there's a way to quote, there's a way to get amount of tokens out, get amount of tokens in, get amounts out, get amounts in, which is like, I guess the plural multi-call version of that. So yeah, we'll hop in here, and pretty quickly, I think we're probably gonna have to go back to the whiteboard to kind of learn a little bit more about transactions, and just get everyone caught up, to just get everyone caught up on kind of some of the Ethereum, some of the pitfalls of Ethereum, right? So here we go. Yes, question.
So I'm interacting with the router to go ahead and add liquidity to specific pools?
Correct.
Okay.
Yeah, so every time you interact with Uniswap, you're pretty much going to interact with the router, unless you're doing some weird like maintenance stuff or like recovery stuff. You even use the router implicitly to create new pools. So if you wanted to go and create a new pool for your token that you just made called, dad token or whatever, because you just had a son, then I don't know. Then you'd go and you'd supply liquidity, and you would create that pool for the first time, and we'll see how that works. I don't know. That's a random
What are the
example.
benefits of, I guess, interacting through the router as opposed directly with the pools?
So that is the whole topic of this meetup, and we'll see how that kind of plays out. at a very simple level, it provides guarantees for the user. And
What kind of guarantees?
To be continued. Yeah, we'll crack into that right now. So, for example, we're gonna skip over this. As you can see, this function is marked internal, so that's going to be consumed across all these different like add liquidity variants, right? So it's used, if we do a find here, it's used in 3 places: add liquidity and add liquidity ETH. And we'll see how this works here. So like, I guess just to get like feedback in the room, what would you guys be more interested in first? Swapping or like adding liquidity into a pool?
Can we start with maybe creating a pool and
Yeah,
specifying the pairs and whatnot?
perfect. Let's do that. Okay, yeah. So let's start with creating a pool. So that's going to be this function here. So first of all, let's just recap on what a pool is, right? So, and I have a doc here which is which might be helpful to us. So I'm just going to run over this a little bit. So the basic idea, and this is a pool, right? The basic idea of an AMM is twofold. First, the price is represented by the ratio of tokens in the pool. For example, with 2,500 USD stablecoins and 1 ETH, the price of ETH in that pool would be $2,500, you know, as kind of common sense, right? So you could say that the price here is going to be the total liquidity of the USD and the total liquidity of ETH in the pool. And so that's a great place to start, right? So a pool contract is a contract that holds both token A, so we'll say USD, and token B, ETH, right? And will allow users to exchange one for the other. So if I want token A, I got to bring token B. If I want token B, I got to bring token A, because you got to, you know, give back to the pool. So if we're creating a new pool here, first thing we got to do is we got to supply that liquidity, right? That took me a while to realize in DeFi, but like it's like there was that question of like when I first started getting into crypto, it was like, well, wait, how are tokens priced? Like, how do I just create my own token and then suddenly it has a price? And there are, I guess the primary way that you can do that is you just create a bunch of that token and you can create a pool with it, right? So say I show up to a pool, and so let's I guess, there we go, I can drag, okay. So say I have like, I've got token A, which is token A is going to be, cool token, right? Oh, yeah, that's not good. Uh-oh.
There you go.
All right. It's like return of the tech problems. It's not good. Yeah, so we got token A, and then we have token B, which is going to be ETH in this case, just to keep things like simple, right? And so if I want to have a way in which users can trade this token, in which this token has a price, I have to create a pool. And in order to create that pool, if anyone's ever supplied liquidity on like Uniswap to be like an LP or anything like that, you know that you have to provide the token in equal value. So like what I need to do is I need to create a new pool contract that is far too small. So I'm going to create a new a new pool for that, and then I'm going to supply token A and token B relative to my price. So what I'm going to do is I'm going to come to the Uniswap router, and I'm going to say, okay, here is 1,000 cool tokens, and then here is one ETH. And so I have to supply liquidity on both sides. Is that tracking so far? Cool.
I think actually it might be helpful for anyone to know like the traditional way. The reason like it has to be done like this on chain is because normally if you go to like an exchange, there's a central like intermediary that provides like the depth and the like. So there's bids and asks for people trading things, and they match those orders, and they're the ones who execute that and they hold the liquidity. So this is like on chain. How do you do it without that centralized provider? And then the pool is like that smart contract without that. So I know that's helpful to anyone, but
Yes.
yeah.
Yes. Yeah, no, that's a great point. Is it like, yeah, normally you say, in a normal model, you say, hey, Bob is willing to accept, 10 ETH for 1,000 USDC, and Alice is willing to accept, 10.5 ETH for 1,000 USDC. And you kind of let the market determine which prices are good and which prices are ridiculous. But in this case, it's more like Alice and Bob put all their tokens, both tokens that they all have, into a pool, and depending on what the market will take, the price is determined by the pool itself. So, like if I'm creating a pool, I'm gonna come to this pool and I'm gonna provide 1,000 cool tokens and 1 ETH, and then so.
You want to do 2,000 cool things.
Yeah, I guess so, right? and so my price is going to be like, oh, maybe I should have done like USDC instead. I'm gonna say like, yeah, to make this even simpler, I'm gonna say if I'm supplying this between like USDC and cool tokens, if I come up to the pool with 1,000 cool tokens and 1,000 USDC, and then those tokens exist within the pool on both sides, right? Like you have USDC and cool tokens, and they trade there. You'd say that the price, the price is going to be relative to the ratio between token A and token B. And so, if you're pretty good at math, you could say that 1,000 divided by 1,000 is 1. So if I wanted to buy cool tokens, I could buy them for $1.
Up to a point, right? Because the curve.
Exactly. So we'll see kind of how that math plays out. I guess we could go into that for sure. But I guess just for kind of this first take here, like how we'd get started here is if we wanted to create this pool for the very first time, we would come to this this contract, and we would call add liquidity with token A. And so token A, as you can see, is an address. So that would be like the cool token address. And then this would be like, the USDC address. These amount A desired and amount A min is going to be this is going to be like the min amount that Uniswap will accept, that the pool will accept for on both sides. And then this is going to be like this is not in the case of creating a pool. This is more in the case of adding liquidity, and we'll talk about why these safety parameters are on here as almost like a guardrail in a second. But this is the amount of liquidity tokens, LIQUIDITY tokens to add the user wants. So we'll like I said, just hold on here. We'll see how this works in a second. This is going to be the to address. So this is going to be the address which the user will, the address to which these tokens will be minted. and then the deadline is going to be I guess like a time limit, right? Which says that like, hey, after a certain amount of seconds, if my transaction doesn't happen, that this contract reverts. So really, like, kind of back to the whole periphery core model. All you need if you wanted to directly interact with the Uniswap pool contract is you would just need to say token A, token B, and then the amount. Actually, I think all you need is token A and token B, and then the pool would determine the amount. But like these are the parameters that allow you, minus the two parameter. That's more of like a message sender thing. But these are the parameters that allow you to do that safely, and we'll talk about why in a second. But right now, I just like want to cover this like add liquidity use case. You can see what that looks like. And so this contract, this will then called add liquidity. And then here's kind of that code there where like it will look up the pair address for token A and token B. So there's like a predetermined pair, Uniswap pair contract for every single like version of token A and token B. And then so like if that pair doesn't exist yet, then go ahead and create the pair with token A and token B. And that will sort of handle the initialization of the pool, and it will pull in tokens.
Those who know check for like token B and token A in that order as well.
So it does actually. Let me show you what this factory contract does real quick. It was built in an era of gas inefficiency, so it's a little goofy, but so as you can see here, there's this mapping of address to pair. So this is token A, token B, and address, or token B and token A and address. So it allows you to kind of like look up these things, and you'll see what this looks like in create pair, right? So like here, my VS Code extension does like this nice little box around any kind of storage variable. So see here, we're setting a storage variable. So basically, we're gonna get a address from creating the pair. So we have a pair address that exists at like a fixed address on the blockchain. We're gonna initialize that pair, and then we're gonna set this storage variable to look up in both directions. So token A, token B equals pair, token B, token A equals pair. And we also store it in an array. So like crazy over amounts of storage happening in this case, but granted it only happens once when the pair is created. Good question, right? So like you could swap this out. You could do token B, token A, and then it'll do the same thing. It'll just perform that lookup in both directions, and it kind of it handles that for you in a way that's safe. So what it'll do first here, like normally it assumes that if you're adding liquidity to a pool, that it'll already be there. If you're creating a pool, this contract will also handle the creation of the pool for you as well.
Real quick, the factory, you jumped from router or from the periphery repo over to core repo at that point also, yeah?
That's totally correct. So if I go back to Uniswap here, you'll see that in the contracts you have the two contracts that you need to worry about here are like the factory and the pair. The Uniswap V2 ERC20 is a base contract. Is it? Yeah, it's pretty much a base contract that the pair uses. So like every pair contract is also an ERC20, which will mint you an LP token. I don't know if you guys are familiar with like an LP token, but like it represents how much you've put into a Uniswap pool. when you supply liquidity. Yeah. So that happens on the core contract there. There's a factory, and the factory has this just has the responsibility of creating the pair, right? So yeah, it has this one function here on here called create pair, and then allows you, if you have the permissions, to also set the fee, which I don't believe is set. That's like a protocol fee. So yeah, this factory will go and create every pair contract in a way that's efficient, and then it will also store that pair contract as like a way to perform like a lookup whenever you need to look, like, hey, I have token A and token B. Is there a pair for this already? Does this trade on a market? If you need to do that on chain, this factory will keep track of those pairs for you so that you can do lookups. Yeah, I think I'm gonna skip over some of this stuff and go back to I guess what would you guys prefer to talk about? Would you care to talk about like the details of how this function works, the add liquidity function, or should we talk more about like amount A min, amount B desired, like these different like protecting functions, you think?
Yeah, can you shed some clarity on that?
Yes. Yeah, absolutely. So yeah, let's talk a little bit about the mental model for how Uniswap itself works, right? So there's this contract, right, which is like it's a pair contract, and it exists at a fixed address. It exists at a fixed address on ETH, and then there I go again. It exists at a fixed address on a blockchain, and it holds tokens, right? So it holds token A and token B. There's how transactions work on Ethereum is there is like this there's this public thing called a mempool, right? And so you have all these different users who want to submit transactions. So you have users and you have transactions, and all these users want to submit transactions all the time. And so what they're going to do is they're going to create these transactions, which are going to do certain things on the blockchain, modify state, send tokens, do whatever they'd like. And then they like sign those transactions and then put them into the mempool, right? And so the thing about the mempool is that it is a place where all your transactions go to live before they've actually been finalized on chain and counted as part of like a block. So you've got blocks here. You've got and blocks happen in chains, right? I think we all feel like comfortable with that, right? Where there's one block, and then 15 seconds later or whatever, there's going to be another block, which is just like the network agreeing to write all these transactions into this next block, right? So the block is made up of different transactions that modify state, but the thing is that all these transactions will go here and they'll live on the mempool before they're submitted, right? So I could go and submit transactions on the mempool and I could say, hey, I'm willing to pay half a cent for that, right? And it'll sit on the mempool forever because it's actually it's not profitable or doesn't make sense to include that in the next block because me as a validator, it doesn't make sense for me to do the computation to include your block because there are a million other people who want to pay me $3 to write their transaction on the blockchain. So here's the caveat though. of a mempool is there are two different things. There are two different caveats here that are really important in trading platforms. The first caveat is that like transactions can happen at any time. So, or I guess maybe a better way to say that is like transaction execution is not guaranteed. Oh no, I don't know how to spell G-U-A-R. No. G-U-R-A.
We know what you mean.
Yeah. All right.
They're not promised.
Man, this is being recorded. All right, there you go. Is not promised. So transaction execution is not promised. It's not guaranteed. So transaction execution is not like when it will be executed. I'm sure you've seen that, right? People complain that the transactions get stuck on chain, right? So like transaction execution is not guaranteed. The time at which transaction is guaranteed is not guaranteed, and then like transaction order is determined by the I guess what is that called? Shoot, the builder. Yeah, the builder, the block builder. The block builder. So, like, why is that important, right? Why is that important when we're building a system for decentralized trading?
Because the transactions ahead of you change the price by the time you get to yours, right?
Exactly it.
It's also public, also worth noting.
Oh, yeah, so that's how front running works too, right?
100%.
Yeah.
Yeah. So two massive issues, right? Just to like recap for the recording, right? Like, if your trade is public, your trade by definition will change the price of an asset in a particular market. So the market in this case is the pair, right? Because there might be other markets for token A and token B, but you've got to interact with this market in order to make a trade, right? So one, I'm saying, hey, I want to trade token A for token B at a certain price. Everyone can see that. If you're trading a ton of token A for token B, you're going to move the price a lot because it's less valuable. I'm not going to go over that here, but I'm going to like include resources in the HackMD to sort of like visualize what that looks like on a curve, right? Because like I'm sure you've seen that like classic curve where it's like, well, yeah, if you divide the token A by if you divide token A by token B, you could say that like the price is going to be like $1,000. But the moment you start trading, you think about it, you start putting in more and more and more of token A, that's going to move the price up the curve, thus increasing the ratio and thus devaluing token B. So it's like you actually get less. I don't know if you've ever tried to trade like some crappy coin and it's like slippage 10%. It's because there's not enough liquidity to support your trade, right? So so that's just to I guess get everyone on the same page to say that like trading actually will affect the price of whatever assets you're trading, even if it's a minuscule amount. It's not promised when that will happen, and then also too like transaction orders determined by the block builder. So this goes back to our bad broker example, where if I called my broker, I'm like, hey man, sell all my ETH. And he's like, okay, cool. I'll get back to you. And he's like, I wanted to sell my ETH because it was peaked at 4K, but it tanked over the weekend. And then my, broker sold it all on Monday. And so I only got, 13K for my ETH. I'd be pretty pissed off, right? So like it's the same thing with the mempool. Is transaction execution is not promised. It's not guaranteed. So I have to build something into my smart contract that says I want both. I want maybe like the time at which my order executes to be atomic, meaning it's like either it goes or it doesn't. It either happens this weekend or it never happens at all, right? Because once you submit, here's also the thing, right? Is like I mean, I guess you could cancel your transaction, but it gets a little shady, right? It's like transaction execution is not promised, but also transaction execution can happen at any time. So like maybe you do submit a 1 cent gas price, but for some reason someone wants to include it, even though it's not economical. They can snag your transaction immediately and put it in, right? Or they could wait. They could wait. They could wait an hour. They could wait 3 days, right? It's really up to. It's a pure free market for transaction execution, and so kind of all these things accumulate, and they come together in a way which says like, okay, maybe my trade won't execute until Tuesday, right? Or maybe my trade won't execute for the next hour. But if you've ever watched ETH price, a lot can happen in an hour, right? So say I submit a trade that I think looks like a good price, because like ETH is trading at $1,400 right now, so I go to sell. But in an hour, ETH might tank to 800 or something crazy, right? Maybe there's a huge sell-off. It's even like non-economical for me to wait an hour. So I want to specify like, hey, I want to sell 1 ETH and the minimum amount I want to get back is 1,300, right? Then you're protected as a user. Because maybe by the time your transaction goes to be executed by the block builder, maybe the price of ETH is 1,000. So let's look at how that plays out in the logic. Add liquidity is kind of a derivative of adding price in a way, because depending on the price, that also determines how many liquidity tokens you'll get back. So I'm actually going to look at how the swap. Yeah, let's look at how one of the swap functions does it. See if I can find one without path. Actually, maybe let's just I think remove. Yeah, this will be fine. The add liquidity amount. So yeah, sorry guys, kind of okay, let's just step through like how this works here. So first we're going to ensure our 3 things, right? So as you can see, as a modifier here, it's ensuring the deadline, right? So ensure deadline, require the deadline is greater than block.timestamp. So that means for me that like I want to ensure that this trade happens before a certain time. So maybe I give it an hour expiry. Maybe I just give it like a 2-minute expiry. If I'm looking to really hop in as prices are rapidly decaying, I can specify that as a user, and that keeps me protected. So I specify my deadline for this transaction because, like we said, the transaction can sit on the mempool for like an hour or days, right? There are transactions that are just stuck kind of in perpetuity, like in eternity out there. This add liquidity function will actually handle the require statements here. So it's going to quote me the amount that I get back. So the amount be optimal less than or equal to the amount be desired. So like first, like what it's going to check is it's going to check to see like, hey, like how many tokens can this pool actually give me at this point in time, right? Because just to clarify as well, in these blocks, right, on as these blocks are being written, like on ETH, like something that I didn't realize is that transactions are executed in order, right? So like for example, I might want to swap a certain amount of tokens in this transaction, but this transaction before also swaps a crazy amount of tokens as well. So like it throws the price way out of balance, right? So maybe this swaps like 1,000 A tokens, and now my price in the pool is going to be not what I expected, right? So like since the transactions are executed in order, we need to we need to ensure that like we're within those safe kind of trading bounds, right? Because there's no guarantees here. So remember that amount B min and amount A min are what the user specified as inputs, right? So it's saying, hey, it's asking like, I guess the pool, like what's the best price that this pool could currently give me? And then if it's anything less than the amount that you have specified is okay for you, then it will revert. So kind of that's how this works, right? It puts revert parameters around your specifications of like what you say is okay for you to trade. So like maybe at the time you clicked the confirm button on your MetaMask, everything looked good from the interface, but by the time it got included on the blockchain, actually the pool literally can't provide you a price that you'd like. So it gives you a way to bail out of the transaction entirely. And so that, and if we look at what this function finally does on the pair contract itself, right? What it does is it calls mint, and it gives liquidity back to the caller, or I guess to the specified to address here, after it transfers both token A and token B to the pair. So it's taking token A from the message sender and transferring it to the pair at the certain amount, taking token B, doing the same, right? So if we look, here's kind of the rub of like the separation between the V2 pair and the V2 router, the periphery, the core contracts, however you want to call it, is that if we look at the mint function, if we look at the mint function, notice here it says this is a low-level function should be called from a contract which performs important safety checks, right? All I have to do is call the to function, right? All I have to do is pass to in this function call, and it will handle itself based on whatever kind of token balance it has that like you transferred to it. It will just mint whatever amount of tokens. And that really might be like financially non-advantageous for me. I might lose a lot of money in just doing that, right? So there's none of these require statements, right? So all it does is it just requires that liquidity is more than 0, so it's not minting 0 tokens to me in this transaction. But if you notice that there's no safety checks here, right? It's essentially it's a smart contract system design that makes it risky for me to interact with this contract directly and inappropriately, but makes it safe for users to interact with it through the periphery.
Can we take a look at that lock modifier?
Oh yeah, the lock modifier, absolutely. So the lock modifier in this case is sorry.
No, never mind.
Yeah.
So I guess, so it looks like it's just mutex, so it's preventing that method from being invoked in parallel.
Correct.
Is there any restriction as to who can call that method?
Nope. No. There's no restriction as to who can call the mint method. There's no restriction as to who can call burn or swap or skim or sync. It's all permissionless and can be done by anyone.
Is the lock modifier basically for reentrancy?
Correct. Yeah, it's a home rolled reentrancy. You can read the lock modifier as non-reentrant. So it's the same thing. But yeah, I guess just to get like a temperature check of the room. I know I've talked a ton. Like, is this making sense? Am I going too slow? Am I going too fast? Like, how are we feeling on all this? Like, any questions?
Good.
Do
No,
good?
I think it's good. So essentially, what we're looking there in the core is just like the most basic functionality that anyone could use, but unless you were really advanced in your logic, right, you could mess up very easily. And so then a lot of the benefits come from the router in terms of, I guess, user experience on a programmatic level to stop you from making stupid mistakes.
Correct. Exactly. It prevents you from making stupid mistakes. And it also bundles transactions too, which is really important.
Okay.
So like I keep mentioning that word atomic, and that's really important, right? I could submit multiple transactions to a blockchain, but they could, like if we remember our caveats here, that transaction execution is not promised. The order is actually not even promised, and like it can happen at any time. So like, yeah, say I could go to this, if I look at my router, right? If I look at everything the router is doing, looks like it's, my thing isn't helping me, but this is an external call. This is an external call, and this is an external call. So if I myself wanted to transfer token A in one transaction to the pair, transfer token B in one transaction to the pair, and then like mint in the third transaction, like there's no way that I could guarantee that transaction, that all three of those transactions happen in order. So someone could come in between my transactions and actually mint those tokens to themselves, right? Or, move the price in a way that's advantageous for them, right? There was a whole bunch of things that they could do. So I have those three options, right? Is I could go to token A and make my own smart contract call and submit it to the chain, token B, and then to pair and kind of do that, create a transaction for all three of those. Or I could go to the router and in one atomic transaction, just call add liquidity with a certain parameter. It's like almost like the router is a composer of transactions that the protocol engineers have determined that are safe for me to use. And then they bundle those up for me in one transaction and ensure that they happen all at once. Because like we said, transaction execution can happen anytime, but also, transactions are executed in order. So yeah, like that's kind of the caveat there, is it adds to the atomic. You could just say like, hey, add liquidity instead of being like transfer, right? Mint. And that's the killer pattern, right? Is that like you have a core contract that is designed in such a way that is just does a few basic things, easy to audit, easy to build invariants for and to formally verify. But then the periphery is like the orchestrator of how to use that, right? It's the API, it's the on-chain API for those things.
Yeah, so could you say the end user would be interacting with the periphery, still not the core? So the core has like some safety and stuff built into it, but you still don't want to be interacting, unless you know what you're doing or some specific use case, you still don't want to be interacting specifically with the core as an end user.
Yeah, never.
Yeah.
Never. Because the core is designed in a way that makes it fundamentally dangerous to interact with it, but is fundamentally and always safe for the core.
Right.
Which is kind of like the cool part, right? It's like, it's
Basically the guardrails.
yeah, it's the guardrails, right? Is the core doesn't have any guardrails. It's like the whole keep the change model, right? Like if you're trying to interact with the core will always take your change, right? It'll always mess you up, right? It's the
shitty broker.
Yeah, you're in Bogota, you have to walk through the crappy neighborhood to get back to your hotel, and then like the periphery contract is the Uber. It just gets you through safely, right? But yeah, thoughts from there.
All of the transfer helpers, are those independently atomic? That they're essentially async external calls, so they all happen whenever the entire transaction reverts, or can
Yeah.
sub methods fail and then the transaction still goes through?
That's a great question, and that's something that you have to actually formally that you have to verify yourself. So if we go into the let's see, the Uniswap contracts to look for the transfer helper. Let's see, this is in V2 core contracts. Oh, this is in lib. Yep. So lib contracts transfer helper. So safe transfer from, yeah, I think this is being used. Let me look here. Oh yeah, okay, yeah. So safe transfer from, here's the transfer helper. So it's going to, this is some goofiness. Basically, it's just like, it's going to transfer the token from, oh wait, wrong function. We should be down here. This is going to be transfer the function from to, and then actually it's going to ensure success here. So you see this. So normally you're right. You'd have to go verify. Wait, is this transfer helper atomic? Because it could allow a fail, right? Technically, you could write the code that way. But yeah, it's in a way that's trying to make an efficient ERC20 transfer on behalf of the user. That also handles some weird caveats with like non-compliant ERC20 tokens. And so like that's a good note here. Whenever you're interacting with ERC20 transfers, you always want to use like a safe transfer wrapper. So safe transfer lib from Soulmate is great. A safe transfer lib from ERC20 is great, is a standard as well, because there are some non-compliant ERC20 tokens out there that won't return a success Boolean when you transfer it. Notably, like USDC doesn't return success on a successful transfer for some reason. So you have to have a wrapper around it to ensure that actually happened. Yeah, there's I'm going to add some articles in the HackMD that are interesting. First one is Ethereum is a Dark Forest by Dan Robinson. Is a very interesting read up on how the mempool works, some of the caveats of it, and then like them actually trying to rescue funds from an ERC20 pair contract by using some of these permissionless function calls. So I'm gonna just say like the bits, right? Whatever. So Ethereum is a dark forest. That's a super interesting article that will like really increase your knowledge on how the EVM works if you're interested as well. The next one is a Open Zeppelin talk about Open Zeppelin, about ERC, about like integrating with ERC 20 tokens. Let's see. I'll find it there. But yeah, they're just some interesting caveats. I actually have a whole like YouTube. The dangers of token integration is what it's called. So I'm going to include that because it's just some interesting caveats about trusting ERC20 tokens and what they might mean for your contracts. But yeah, we're coming up on the last like 5 minutes here. I guess, yeah, any other final things that you guys like want to go through? I know we didn't even get to like swapping, but I think we covered some like important basics of like transaction ordering, front running, like back running, like how people could use your like atomicity of like of contract calls, how you want to build your ecosystems, but yeah, like any other kind of like, maybe we could get like one or two other things that we could look at in the code before we
I've got
stop.
more a high level question.
Yeah, go for it.
From a architecture overview, how would you start creating this whole repository if you were starting from scratch? Like what would be done first, the core? And if so, which contracts within the core?
Right. Yeah. So actually, I listened to some great talks I got to go to Bogota and listen to some great talks from some security engineers at like Certora and runtime verification and some just like killer auditing firms. And they've really they were pushing like Solidity developers to begin with like this sort of like spec first design, invariant first design. So actually, really briefly, I want to show you what I've been doing for my for like these V2 contracts that I'm building, and how I'll actually build out these features from an actual spec first, and then how they get implemented. So like, for example, I needed to create this function called permit pay claim. So what I did is I said from a high level, it allows a user via signature to approve an operator to call this function on their behalf, right? And then I wrote out a spec first. I wrote out a spec before I ever wrote out code. So I said, here's the spec. Anyone can call this function with a valid signature to modify the owner's approval for operator, blah, 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 parameters. So, and then I said, I laid out the guardrails for what the spec actually was. So this function can approve an operator given, and then I wrote, these different spec cases, A1, A2, A3. So approval cases 1 through 4, revoke cases 1 through 4. A valid signature is defined as the following, signature 1 through 8. And then if the above spec conditions are true, yield res 1, 2, and 3. And so I wrote all that out before I even started writing my code. Notice that these specs can be actually referenced inline, which is really nice because it allows an auditor to actually follow along like, okay, like these certain security guarantees or these logic guarantees are actually being maintained in line. And so that there's verification around that. So yeah, I guess in like a very long-winded way to answer your question, in terms of protocol design, what you'd start with is you say like, okay, like, in code school, I had someone break down like how to do like an interview, like a whiteboarding interview, and they're like, write an input and output table. Say like, okay, given input A, do X, right? And so like, I would start with that, like start riffing on an input output table, like do invariant first design. What are some of the things that this smart contract, which is kind of like a settlement layer for different users interacting with your protocol, what is this smart contract what logic is it gonna uphold? Who's gonna write? Who's gonna read? Who's gonna like XYZ, right? And so I'd start with the spec first. And then from there, I think you could take a spec an extra layer further, and you could say, is it useful for me to create a separation of concerns, right? So it's like almost like from a spec, you can create a risk analysis because you understand fully what your contract can, could, should, and shouldn't do, right? And then you create a risk analysis, figure out who's holding tokens at what time. I think that's probably one of the most important parts is like ERC20 balances before intra-transaction and after transaction. And then you want to see like, okay, like does it make sense to write a contract that is like a periphery contract, like whether it be like a router contract or like some sort of helper contract, which just is not necessary, but it bundles multi-calls for a user, right? Because you all know we all hate sitting there and saying execute, 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 execute. It'd be nice if I have a multi-call functionality, right? Like that'd be great. So I think that kind of needs to be determined by you, and it's very case by case. But I think it all starts with the spec and then like a risk analysis.
Cool.
That spec blueprint, is that something you came up with yourself, or is that you sort of derived from one of the talks that you saw?
Yeah, this one specifically I came up with myself. I've like very graciously, I'll include the talk, or I guess the notes from this guy named Rickard. What is his name? Yeah, did you see that talk?
Yeah, it's at the time.
Yeah, man.
That was great.
I think they have the recording of it too
Yeah.
on the Ethereum Foundation, like, or the DevCon, wherever they publish those videos.
Yeah, I think you're right.
Yeah.
I think you're right. Yeah, so here we go. It was called Formal Methods for the Working DeFi Dev. And this is a sick blog post. It goes on forever. This is about invariance specifically. And yeah, Rickard is great. Rickard, he's fantastic. You can reach out to him. I've been telegramming him back and forth, and he's been helping me. He's like, he told me that it's great to have like a working implementation where you put your invariance and your spec in the actual NAT spec of the contract. So like, the at notice, at spec kind of stuff where I have it sort of inline. And then eventually what I'm going to do is I'm going to after audit, I'm going to pull that into just like a spec markdown file and talk about, first of all, at a high level, what kind of invariance my smart contract upholds. And then I'm going to have like for each function what the different spec is so that it can kind of be referenced at any time. Because you could write your smart contract in plain English at any time, and it's like probably very useful to do that. This talk was a little bit more about invariance, but I'll include it in the markdown as well. But yeah, I can include that. Yeah, any other questions while I scrounge that up?
Might be on the East Global channel. So I think they're just uploading stuff in both of us.
Oh yeah, that is a good. That's a good point. Yeah, he includes this here. So like Alchemix V2 has like a very robust fuzzing system and like handwritten spec for like formal verification. But yeah. Why is that not copy? Anyway, I'll stop stumbling here. I'll include it later, but yeah, any other final kind of thoughts? I know we didn't get very far through this, but yeah.
So, as far as the pattern of separating the concerns of kind of guardrails and core, right? Is that a pattern that is mostly used in DeFi applications, or is that starting to appear kind of other places as well?
I think it's mostly being used in DeFi applications from what I can see, because I think like the separation of concerns is almost like such higher stakes.
Yeah.
Yeah, exactly, right. Where it's like you're dealing less with logic and users and more with more with tokens. Especially when you're building like permissionless systems, you really have to think about like front running and all these other like environment factors in Ethereum, right? Like, if everyone can see your transactions before they execute, then like everyone knows what the stakes are and how the environment of the blockchain is gonna completely change once your transaction is executed. So then they can do different things to mess with it. There's some really interesting caveats that I can include in the HackMD link, like just-in-time liquidity, front running, back running, different things that you see on these like trading platforms, like MEV. People will pay a certain amount to get in front of your trades, so they can extract a certain amount of value.
Right.
That kind of all sort of happens at the mempool layer. But, yeah. All right. Yeah, that was great. I guess like in terms of next meetup, we've been trying to do these like every 3-4 weeks. We were at Bogota last, kind of when the timing would have been right, but like I guess just while we're here, like any other any suggestions for the next one? Is this format like, and then we'll send out like a survey too, like, is this format useful? Could you think of like a more helpful format? Like, yeah, I guess just like let me know if you have any suggestions for repos or patterns like that. And then yeah, I guess reach out to me at any time. I could put my Twitter, my Discord, and I love like sharing stuff and sharing knowledge. So like if you want to see any of the stuff that I'm working on, that contracts repo that I was telling you about for our V2 stuff is public, and happy to share some all the resources I can, right, so that we can all get better at this stuff. But yeah, sweet. Thanks, guys.
Thank you.
Very good.
Good stuff.
Cool.
Turn the lights back on.
There we go. And broad.